So good evening, everyone. Everyone is over here. Can you hear the sound clearly?
Yes, sir.
Okay. Afan, Ankit, and all. Darshani is Parsa. Injara is new to this class. Okay. So Injara, try to understand the things. If you'll not be able to understand, just ask me. Okay. And even Tony has talked. Please try to solve the questions. And if you'll not be able to understand, just ask me. Right or not? Everyone, Sanjana and all. I think you guys are a little bit preparing less, but this will ultimately result you in a very backdrop. Okay, so you try to concentrate on the classes perfectly and try to solve the questions. Okay, so let us start this class. Okay, so the topic is simple: rest and motion. Whatever we have done, we are going to revise it. For which kind of cases? Non-uniform acceleration cases. So uniform acceleration, non-uniform accelerations, there is a little bit of difference, and we'll try to understand what is that biggest difference. Okay, so if it is a uniform acceleration, acceleration remains constant, just that one word. Okay, so acceleration remains constant for which case? Uniform acceleration. And for that case, simple formulas like acceleration is equal to final velocity minus initial velocity divided by time, and all these kind of formulas will be valid. But for non-uniform acceleration, what will happen? Acceleration will not remain constant. Now, if acceleration is not constant, the meaning of it is what? That non-uniform. I'll just write it non-uniform. So when acceleration is not constant, we call it as a non-uniform acceleration. What is going to happen over there? That since acceleration is not constant, I can physically tell that acceleration is varying with time. So are you able to understand me or not? What is the difference between a uniform acceleration and non-uniform acceleration? In uniform acceleration, acceleration will remain constant. It will have a normal formula, u equal to v minus u by t, or s is equal to ut plus half at square. All those kind of concepts will be applied in easy way. And which kind of equations? Uniform acceleration equation. But in case of non-uniform, the acceleration does not remain constant, and that means what? Acceleration is varying. Okay, so I'll just summarize this. So if you have uniform acceleration, okay, so if you have uniform acceleration, what are the formulas that we can use? A is equal to v minus u by t. Second formula I can use v is equal to u plus at. Third formula I can use s is equal to ut plus half at square. Now look over here. If you go through the equations, all of these equations of motion, what you see? This A is constant. This here A is constant. This here A is constant. It does not vary with time. What is the problem with this kind of equation? You can't change the value of A particle if the car starts on the road with some kind of acceleration. After time t also, it will, this car is going to have similar acceleration. In which case of acceleration? Uniform acceleration. Is I'm clear or not? Tell me yes or no. This kind of basic concept, first basic concept. Is it okay with you guys? Guys, yes or no?
Yes, sir.
Okay. Now, next thing is you can last formula that we can utilize is v square is equal to u square plus 2as. Whatever you check all of this formula, here one thing is very common, that this acceleration is always constant. If acceleration is always constant, that means what? What is going to happen? You will have uniform acceleration case. Okay. Now, next thing is one of the most important point, that we are entering to non-uniform acceleration. Okay. So before going to non-uniform acceleration, like like what will be the theory part of non-uniform acceleration? Okay. So when we are considering non-uniform acceleration, what is going to happen? That your acceleration will not remain constant. What is going to happen in non-uniform acceleration? A will not remain constant with respect to time. What is going to happen, guys? That acceleration will not remain constant with respect to time. When it is not going to remain constant with respect to time, what you can physically tell that A will vary time to time. Just like try to understand. See, means you can take an example like if you have like let's suppose if you consider a car which you are starting from your home, practical cases, what you do, you start to give the acceleration, sometimes you decrease the acceleration. So those all cases are the cases of non-uniform acceleration. If non-uniform acceleration is going to happen, means A will vary with respect to time. One thing you will observe, that velocity is also changing velocity is also changing with respect to time. What you are going to observe that, guys, that if acceleration varies, if acceleration means, like, try to understand, if your car is moving, so try to understand, I'll draw this road, there is a car, okay, if this car is moving with some kind of acceleration a1 over here it has some another acceleration a2 over here, what you will observe here, it will have velocity v1, here it will have velocity v2. So what does it mean? That if your car is having non-uniform acceleration, velocity will be also non-uniform. Velocity will also change like different way. It will not remain changing like, okay, first 1 meter per second, then 2 meter per second, then 3 meter per second. It is not going to happen like that. Are you able to get me or not? So are you able to understand these two differences over here? That what is happening in one case, that your acceleration remain constant in case of uniform acceleration, in second case in non-uniform acceleration varies with respect to time, and the things or velocity or whatever displacement you consider, it will not remain same with respect to time. Are you able to get me, guys? Yes or no?
Yes, sir.
Okay. Now, so whatever we have studied this theoretically, we are going to apply in some kind of mathematical way. But before going to that, again, we'll go through one of the biggest concept, and the concept of uniform motion, in which you guys always remain confused. So if you have uniform motion, I have described this whole uniform with 6 points. So if you have uniform motion in the body, one thing, there will be many points which we need to consider. First thing will be what? Velocity remains constant. What is given? See this, read this line. Velocity may be positive or negative, whatever it is, or zero. It will always remain constant when the body is having what kind of motion? Uniform motion. Velocity remains constant. Velocity is what? Displacement by time. So now try to see if velocity remains constant, what is going to happen, that this displacement will also vary with respect to equal time, right or not? So if your velocity is constant, I'll write it, velocity is equal to constant, that means you have equal distances in equal interval of time. Is I'm okay? So first property of uniform motion will be velocity will be constant, and if velocity is constant, you are going to travel equal distances in equal interval of time. Second case will be what? Speed also will remain constant. What will remain constant in uniform motion? Speed and velocity both will remain constant. Now, if your velocity is constant, means velocity is not changing with respect to time. You know that acceleration is equal to v minus u divided by t. This is final velocity. This is initial velocity. This is time. So if velocity does not change, that means what? Final velocity will be equal to initial velocity. For what case? For velocity to be equal to constant. So that means what? If v will be equal to u, what will be the acceleration value? It will be equal to 0. So in uniform motion, another thing is that, what is that? That acceleration becomes 0 over here. Is I am okay? Are you guys able to understand all of these things? Yes or no?
Yes, sir.
Okay. Any kind of doubt? Inchara, Sparsa, Radha, Parinita, any kind of doubt? Sanjana? No doubt, na? Till now.
No, sir.
Okay.
No, sir.
So moving to next point, let us move. Second thing is coming to acceleration equal to 0. Third thing, displacement. As you know, that displacement is what? May be positive or negative. It can be positive or negative. So I can write in uniform motion as equal to how much? Velocity into time. Just velocity into time. What is the formula of displacement for uniform motion? Velocity into time. It will not have another equations. Like look over here, see this. What is the displacement equation? S is equal to ut plus half at square. Right or not? Displacement is equal to initial velocity into time t plus half at square. So if this velocity remains constant, this displacement equation just changes to u into t. The acceleration value will become how much? 0. So if you have a uniform motion, what is the value of displacement? It is equal to velocity into time. Similarly, if you have uniform motion, distance will be equal to what? Speed into time. What? Speed into time. Next thing will be that these two things, speed and displacement, will be done equally. It will be distributed equally, right or not? So let's suppose if time for time t1 you have displacement d1, then again for time t2 also you will have displacement d2, but this d2 will be equal to again d, right or not? So you are going to travel equal distances and equal interval of time for uniform motion. Last point is that if your distances and speed are always positive, what is going to happen in uniform motion? That distance and displacement are going to, distance and speed are always going to be positive, where velocity and displacement may be positive or negative. As you know, displacement and velocity are which kind of quantities, guys? They are kind of vector quantities. So therefore, they can be positive or negative, while distance and speed are a scalar quantity. So therefore, they will be always positive. Is I'm clear or not? Tell me yes or no. Are you able to understand all of this? Yes or no?
Yes, sir.
Okay, perfectly. These are the simple basic things which we need to understand before going to the uniform motion cases. Okay, Yasin, Vivek, Varun. Again, I'm asking if you will have doubt, ask me directly. Otherwise, it will become a problem. Okay, so you just ask me directly, whatever doubts it is there. Okay, go through this. Just go through this once. If you'll have doubt, you can ask me. Can I move ahead?
Yes, sir.
Okay, so moving to the next point. So utilizing this, we are going to have the equations of one-dimensional motion with non-uniform acceleration. Okay, so give the first heading over here, a differential equation. What? Differential equation. So let us suppose you are aware of equations. Let us have equations of x, means you have displacement, or x is going to denote what? Distance or displacement. Consider it to be displacement. Okay, so what you observe, that displacement of the body is dependent upon time. Dependent upon time means what you are going to observe, that this x will be written in form of t square plus 2t. Means what will happen in the RHS of x, if it is dependent upon time, there will be equation of time. Okay, equation of time means what? In the RHS, in this RHS, what will happen? You will have some equations of time. Equations of time means what? Like t square plus 2t plus 3t plus 4t, whatever it is, word or not. So you will have something written in terms of time. If I say that x is equal to x of y, that means what? This RHS will have only the variables of y square plus y square, something like that. This I taught you in the class, yes or no? So based upon this, let's suppose if you have a displacement which is dependent upon time, on the RHS, what will happen? You will have the equations of time. If you have equations of time, someone asks you that what is the velocity after time t? After time t. So what you are going to do? First you will calculate. First you will take the differentiation of this. So what you are going to do, take the differentiation of d by dt of x of t. What is the first step? Find the differentiation, then you can replace this time with the given time and you will get the answer. What is the step? First, if you see that x is given in terms of time, you just calculate the velocity by differentiating it. If you differentiate it, you will get the answer. Second thing is, if you want to calculate acceleration, you will have to again differentiate it. So you will have to again d by dt you will have to take, then again d by dt of this x. If you do it, you are going to get what? Acceleration. So acceleration means what kind of differentiation? Two times of differentiation of the similar formula, and then you will get what? Acceleration over here. Yes or no? Is I'm clear or not, guys?
Yes, sir.
Is I'm clear? Asparsa, Radha, Nisant, Yasin, Inchara. Are you able to visualize this little bit? Okay.
Yes, sir.
Sanjana, Parinita.
Yes, sir.
Okay. Fatima, Unisa. Who is this?
Sir, it's me, Anurag.
Okay. Okay. Sure. I'll give one example. See, there are many examples which I have included. See this? It's coming. It's coming. Wait. Okay. So before going to this, I'll do one example based upon this. Okay. Now, you try to understand. I did this. Means if you have x dependent upon t, you got the equations. Now, another thing is, if velocity is dependent upon time, what you see? If you see velocity dependent upon time, you can calculate acceleration directly, and you will apply d by dt of v into t. So you will write the equation of velocity. If you differentiate with respect to time, you are going to get the acceleration. Are you able to understand me or not? So what I'm going to do is, I'll divide this whole of this into three parts. Okay, word or not? So look over here. See this. I have divided all of these equations in three parts, and it will help you to understand in a better way. You just make the table like this. I also did it in similar way. So if your position is dependent upon time which is given, if your velocity which is dependent upon time is given, if your acceleration dependent upon time is given, x of t means what? You will have something x given as t square plus something something something. V if dependent upon time means what? Ts v will be written as t square plus 2t or something something something. Acceleration of t means what? It will be given as t square plus 30 t cube or whatever it is. So you see that RHS has only the variables t over here. Then I can call this as all of these equations as x dependent upon time, velocity dependent upon time, acceleration dependent upon time. Now, if you are aware of x at such kind of equation, if someone asks you find the displacement or distance traveled after time t. Okay, so if someone asks you find the distance traveled after time t, what you will do? You will just calculate x of t. Means what you will do? You will replace this equation with the capital T over whatever time it is given. You will just replace over here. So x will be like, let's suppose if you have an equation like this one. I'll take one example of an equation. Do not think that this is the original equation. Just an example it is. So let's suppose x is given as t square plus 2t plus 3. So what will be your displacement after time t? It will be just you will replace this t over here with respect to these variables. So it will become as t square plus again 2 into t plus 3. Right or not? So this is the displacement or distance traveled by the body after time t. Are you able to get me or not? Yes or no? Guys, is this okay? So let's suppose
Yes, sir.
someone asked you that find the distance after 2 seconds. Okay, I'm doing it pure mathematically, so you might feel like, "Arey, what is happening?" So just hold your breath. Okay, do not just get frustrated by this. Okay, because this is frustrating. Okay, so distance after 2 seconds, if someone asks you, so what you will have to do? Just replace this t by how many, by which quantity? Just this two numerical value. Okay, so x of 2 will be given as what? 2a square plus 2 into 2 plus of 3, which is equal to how much? 4 plus 3, which is equal to 8 plus 3, 11 meters. So if your equation, if your position of the particle is varying with this kind of equation, word or not, if it is varying with this kind of equation, and if someone asks you, find the distance traveled by body after 2 seconds, what will be your answer? Just replace this 2 seconds over here, you will get the answer. Understood or not? Easy peasy, yes or no? Is I'm okay or not?
Yes, sir.
Okay. Yeah, this is the only equation. Okay. Ankit, okay. Darshani, okay. Okay. Harshita, are you able to understand?
Yes, sir.
Okay. So these things are simple but little bit tricky. Now, second thing is if someone asks you that find the displacement in similar equation, find the displacement. Okay. So I'll write it in by black pen so that you can understand. And it is a different thing. If someone asks you that find the displacement in some t is equal to t1 to t is equal to t2. So like if someone asks you that find the displacement in time gap from t1 to t2, similar equation is given. If someone asks you find the displacement, what will be that? So I'm representing displacement by delta x. What I'm representing? I'm representing by delta x. So first find the displacement for total time t2, then find the total displacement for total time t1. Apply the negative sign over here, and you will get the displacement. Are you able to get me or not? How to calculate the displacement from the position equation? First, find the displacement for time t2, or replace the variable over here as t2 to t something something like that. Then for t1, similarly replace it, and you will get some numerical value. Subtract this, and you will get the answer. Understood or not? Are you able to get me or not? Okay. So this is the process of doing this kind of problem. Okay. Is it okay or not, guys? Okay. Now, so try to understand if your x of t. Okay. What I'm doing? Let me just minimize this so that I can use some more equations. Next thing is If your x of t is given again, if your x of t is mentioned again, and someone asks you the velocity of the particle, so velocity will be what? D of dt by x. What you will do? Just differentiate the equation. So what you will do? You'll just put like d by dt of x, and you will get the velocity of particle. Understood or not? If someone asks you find the acceleration of particle, you will have to again do double differentiation. So that means what? D by dt and again d by dt of x, and you will get what? Acceleration over here. So these are the four forms of x of t. First, to calculate displacement, we need this kind of way. Then you can use the displacement, distance and displacement for calculating. Then you have to apply differentiation to calculate velocity and double differentiation to calculate acceleration if your position time equation is mentioned over here. Understood? Easy peasy? Yes or no? Now something is entering into the brain or not?
Yes, sir.
Okay. Is I'm okay or not, guys?
Yes, sir.
Okay. Now look over here. See, moving to the next part, going to the velocity time equation. So if your velocity is given dependent upon time, what you are going to do? So if your velocity is given, someone will ask you about the acceleration. Okay. So velocity is varying. So many people will ask that what is the acceleration of the body? What you are going to do? You just differentiate d by dt of velocity, and you will get what? Acceleration. What you are going to get, guys? Acceleration. Now, if someone asks you that if the velocity, try to understand, you are driving a bike, your velocity is varying, but still you will travel some distances or not. Tell me yes or no. So, how to calculate that distances? It will be equal to, so if someone asks you find the distance, then what will be that distance? It will be integration of velocity into time, which is velocity equation, which is dependent upon time, into dt. What? Velocity dependent upon time into dt. If you do, you will get what? Distance traveled by the body. Understood or not? Simple things. Okay. Are you able to get me? Yes or no?
Yes, sir.
So as you see this, as I already told, you have the equation velocity is equal to dx by dt. So from this is from where it is arriving. So if you write dx is equal to v dt, and you know that if I apply the integration, I'll get the x over here, and it will be equal to integral v dt. So these are the two formulas from which, like if you want to calculate acceleration from the velocity equation, the formula which will be utilized is this. If you want to calculate distance from the velocity equation, you will be applying this formula. If someone asks you find the displacement from the velocity, okay, so displacement will be between some time, yes or no? Displacement will be from time t1 to time t2. Similar equation will be there for the displacement, and that just one thing will change. Here one time t1 limit will come, and it will be from time t2, and this will be similar p of t into dt. So that is the way. Okay, so from velocity, if someone asks you acceleration, you will apply this formula. From velocity, if someone asks you distance, you will apply this formula. From velocity, if someone asks you find the displacement, just change the limit from which time to final time. This is my initial time, this is my final time, and I'll again integrate it, and I'll get the answers. Understood or not? Tell me yes or no. Simple.
Yes, sir.
Okay. Last point is of acceleration, which is dependent upon time. Again, see, this is time equation. So if someone asks you find the velocity, so as you know, after acceleration, there is nothing to differentiate. Yes or no? Jerk is there, but it is not going to be utilized in your classes. So velocity, if someone asks you find the velocity, like from acceleration, we can either calculate the displacement or either we can calculate the velocity. So if someone asks you find the velocity, what will be that? Integral of, this time again integral will come, and it will be equal to what? A into dt. Are you able to get me or not? What equation of acceleration you will have to put, and you will have to put dt, and you will get the velocity. See this, what is that? If you have velocity dependent upon time, to calculate acceleration you need to differentiate. If you have acceleration dependent upon time, to calculate velocity, what you need to do? You need to do integration. Are you able to get me or not? Easy peasy. Yes or no? Till now?
Yes, sir.
Inchara, are you able to understand? Okay, these mathematical things will be a little bit different, but try to understand it. Hey, is this Dhanusri? Dhanusri, Dhanusri, are you here? Ankit, समझ में आ रहा है ना? Nisma, is it clear or not? Sanjana, Sneha, Sparsa, Varun, is it clear?
Yes, sir.
Okay.
Yes, yeah.
Okay. Harshita, now is it okay or not? Means, are you able to connect the equations?
Yes, sir.
Radha, can you connect it?
Yes, sir.
Okay. Your marks is very much less, Radha. Please focus. Please focus. Start focusing. So velocity, if you want to calculate from acceleration, it will be integral of ADT. And if you want to calculate displacement from the acceleration, okay. So if you want to calculate displacement from the acceleration, whatever you will get the equation of velocity from here, you will just have to integrate it once more to get the displacement. What is the relation? First you will calculate the velocity from acceleration, then you need to calculate the again integration of velocity dependent upon time, and then you will get what? You will get the displacement over here. So this is an exceptional case. This will not be asked in your MCQ kind of questions, or sometimes it can ask you. It's like in a simple form, okay? But you can do it easily. Understood or not? So these are the basic formulas which are there in whole of these non-uniform cases. Understood? Not extra will not be there. Again, I'm saying there is nothing extra over here. Okay? Is I'm clear or not? There is nothing extra. These are the formulas which I'm going to utilize. Okay? 1 minute. Let's switch off this mic. Okay? Is I'm okay or not?
Yes, sir.
I think yeah. So this was the concept which you guys were missing. That sir, like there were many equations suddenly I was using and you were not able to visualize. So these are the only equations which I am going to utilize, and you will see that how I am going to utilize. Just you see what is given in the question. If x is dependent upon time, these kind of formulas will be applied. If velocity will be dependent upon time, this kind of formulas will be applied. If acceleration is dependent upon time, this kind of formulas. Not even a single formula more than this I will be applying over there. Understood? Okay, okay. Yes or no?
Yes, sir.
Okay.
Yes, sir.
So let us start doing this, and we are going to utilize this whole of these things or whole of these concepts in the questions, upcoming questions which we are going to solve. So first question is this: for a particle, displacement time relation is given, which is equal to t is equal to root x plus 3. Its displacement, just little bit of logic here it is given. Its displacement it is asking when the velocity of particle is 0. So do it, little bit do it. Now the things start properly, okay? This is where your logic will work. You understood the concept, apply the things, okay? Okay, how to understand the question? Okay, I'll just discuss one or two questions over here. See, equation of the particle is given. T is equal to root x plus 3. I will write this. Okay, I write this. T is equal to root x plus 3 given for the particle. What it is asking? It is talking about displacement. So first of all, displacement should be on the LHS. Second thing, it is again talking when it's the velocity of the particle is 0. Now, as you know, here for time I gave any kind of three, did I made any kind of equation for the time? No, I didn't made it. So you have to convert the time equations in which kind of equations? Either in form of x of t, either in form of v of t, or either in terms of a of t. So like look over here, here it is given t is equal to root x plus 3. I can just write x is equal to what? I'll bring 3 over here, I'll bring 3 to the LHS, it will become what? 3 minus 3 whole square. Yes or no? Now look over here. Isn't the time is on RHS? So is this is the equation of x of t or not? Tell me yes or no, guys. Yes or no? Now it is asking what?
Yes, sir.
Displacement of the body when velocity is 0. So first you need to understand about velocity. So if you know x is dependent upon time, what is the equation for velocity? It is equal to d by dt of x. Simple. Yes or no? Yes or no? Is I'm okay?
Yes, sir.
Okay, now look over here. How to solve this? So it will be equal to d by dt. Right, the equation x is given as t minus 3 whole square. And look over here. What will happen? You know that. What is the formula? See, as you know, I gave one formula d by dt of t to the power of n. If there is a something like this, so what will be the formula? It will be equal to n to the power of n minus 1. So I can consider this whole term as what? T. What it will become? So d by dt of t minus of 3 whole square. N value is how much? 2. So answer will be what? 2 t to the power of t minus 3 to the power of 2 minus 1. Yes or no? Is this is going to be the form or not? Tell me yes or no. Is I'm okay? So this will be what? 2t minus 3, and this is what? Equation of velocity. Are you able to get me or not? So from the position time, if position is dependent upon time, I got my velocity equation like this way. Velocity is given as what? 2t minus 3. Is I'm okay or not? Everyone, tell me. Nissan, now are you able to understand? Afan, Dhanusri, are you able to understand? Sanjana? Okay, so look over here, see this. What I told, let's suppose if your x, what I did, your time was given was root x plus 3, but in these three boxes, I was not having any kind of time equation over here. Okay, so if time is given, there is no formula for that. So you need to convert your equation either in form of x of t, either in form of v of t, or either in terms of acceleration time. And that's what I did over here. I just replaced this. I just tried to form an equation of x because x was given over here, so that I can utilize these kind of formulas. If I tried it, what I got as an equation, x is equal to t minus 3 whole square, and that is my x of t. Now from x of t, if we want to calculate velocity, look over here, already I gave this formula. 1 minute. Okay, I gave this formula of velocity. Velocity is equal to what? D by dt of x. So what I applied, it is d by dt of x. So now x is equal to what? T minus 3 whole square. I put it over here, d by dt of t minus 3 whole square. Now try to understand, if you are applying the formula, if you are applying the formula of differentiation, then there are some formulas over there. What are the formulas? First formula is, if t to the power of n is given and there is a d by dt is mentioned, what is the net result of this value? It is equal to n t to the power of n minus 1. What is the value? N t to the power of n minus 1. Got it or not? So if you apply d by dx of x to the power of n, what is the formula? Nx to the power of n minus 1. Instead, are you able to understand these formulas first? Tell me. Okay, now look over here. T minus 3 is t is my form, and this is a constant term over here or not? Tell me yes or no. Injera. Okay, now if it is a constant, the formula will remain same. If it will be like t minus t square, something like that, then you need to first solve this big bracket and then you need to answer. Okay, if it is constant term, just leave it in a simple form. Okay, so what I will do, it is t minus 3. I can apply this direct formula. N value is how much? It is equal to 2. So what will happen? N to the power of n minus 1. So I got the resolution as what? D by dt of t minus 3 whole square as n, which is my 2, and t minus 3 to the power of 2 minus 1. Understood or not? Okay, so let's suppose if velocity will be given as d by dt of t minus 2, t minus of 2 whole cube, at that time what you are going to do, just n value is what? 3. It will become what? 3 t minus of 2 to the power of 3 minus 1. What I get as a relation? 3 t minus of 2. 3 minus 2 is how much? 3 minus 1 is what? 2. So therefore, what is the velocity of velocity equation you will get? 3 into t minus 2 whole square. Understood or not? Now is I'm clear? Okay, so what you got the velocity for this equation? Velocity is equal to 2t minus 3. What it is asking, actually you have to calculate displacement. What you have to calculate? Displacement. But for what case? For when the velocity is 0. So first find where the velocity is 0. So I'll put velocity is equal to 0. That means what? 2t minus 6 should be also equal to 0. So therefore, if I write t is equal to 3 second, that means what? At t is equal to 3 second, what is happening? The velocity of particle is becoming 0. Now everyone is able to understand at what time your velocity of the particle is 0. Yes or no? Guys, yes or no? Okay. Now, okay. Now look over here. What it is asking? Displacement. Look over here. See this in this graph, in this box. How to calculate displacement at time t? Just you have to replace the value of time. Yes or no? So to get that particular time, what I did, I used these methods to get the time. So at t is equal to 3 seconds, what is happening? Velocity of the particle is becoming 0. So displacement at t is equal to 3 is going to be equal to how much? It will be equal to, put this 3 value over here in this equation. We will get it 3 minus 3 whole square, which is equal to how much? 0. So what is the displacement of the particle as t is, when the velocity of the particle becomes 0? It is equal to 0 only. Is I'm okay or not? Everyone? Are you guys able to understand? Inchara, Yasin, Harsita, Afan, Sneha, is it okay or not? Varun? Okay, are you able to understand? Nisma?
Yes, sir.
Okay. Harshita? Okay.
Yes, sir.
Okay. Meaning Harshita, Ankit.
Yes, sir.
Okay. हाँ बेटा तुम भोजपुरी गाना सुनो ठीक है ना चलो so let us move to next question again these questions will clear a concept when you solve more question more concept will be clear now see the question what it is given now here position of object moving along where moving along the x axis is given and this is equal to x is equal to a plus bt square I'm writing is x is given as a plus bt square now look over here again on RHS time is there so no need to change it has already given that x is equal to x of t where a has value 8.5 b is given 2.5 it is asking its velocity at what time you have to calculate at t is equal to 0 what it is asking you have to calculate velocity of the particle when the time is equal to 2.0 second yes or no now look over here again x is dependent upon time yes or no I have verified that x is dependent upon time if x is dependent upon time how to calculate velocity simple d by dt of x yes or no write the equation d by dt of a plus of bt square yes or no is I'm going to write like this way or not tell me yes or no now do the differentiation I have done in the class already try to do it try to do it try to do the next thing and calculate the answer everyone I'll not do the next things okay do this question anyone did you guys got the answer anyone oh bhagwan ji it is taking so much time hello guys can you hear me or not
Yes, sir.
so what has happened velocity is what d by dt of a plus bt square can't you solve this question I think you are getting stuck in differentiation. Now look over here. How to solve this? First, I'll multiply this d by dt to the terms. First term is a plus d by dt of bt square. Yes or no? Ankit has calculated and answer is 10. Okay, Ankit, I'll just take it. Now look over here. A is a constant term over here or not. Look over here. A is given, it is equal to 8.5. B is given, which is equal to 2.5. So if you take the differentiation of a constant, remember that if you take d by dt of any kind of constant, the answer will be equal to how much? 0. So this value becomes how much? 0. But if a constant is multiplied with the variable, what will happen? Constant will come out. So b will come out and d by dt of what? T square. Are you able to get me or not? These two steps are over here. Two important steps are over here. What? You have to first differentiate the constant which will be equal to 0. Then you have to see the equation next part where you observe that constant is multiplied with the variable. What I will do, I'll just bring the constant out and take the differentiation of variable. What I am going to get? B. And as you know, d by dt of t to the power of n. Here n value is how much? 2. So what will be the relation? 2 t to the power of 2 minus 1. So what you got as velocity? 2b into t. What you got as velocity? 2b into t. Are you able to understand everyone? Yes or no? So what I got as velocity equation, it is equal to 2bt. Yes or no? Guys,
Yes, sir.
okay. Inchara, okay. Harshita, are you
Yes,
here?
sir.
Harshita,
Yes, sir.
are you solving or not? If you will not solve, solved already. Nesma, okay. Parinita, Parinita,
Yes, sir.
are you solving it or not? So if your velocity is given as 2bt, I got, so what I will write? 2 into b value is how much? 2.5. At time, what I have to calculate? 2.0 second. I'll put over here 2.5 into t. So that is equal to how much? 10 meter per second. So velocity after 2.0 second is how much? It will be equal to 10 meter per second. 10 option C is correct. Okay. Please look at the questions. So I will do some parts of the questions or not. I can't solve all the things. Okay. If I solve, what you are going to do? X, I got X from the X, I wrote the equation of velocity. Then it is your task to solve this differentiation. Okay. Can I move to next part?
Yes, sir.
Okay. Moving to next question. Question number third. Solve this question. Apply the logic first 2 minutes. Who will make me understand this question? Just tell me. Harshita, can you explain this question? Harshita, open your mic.
I'm reading, sir.
That much time you will take for reading. I will kill you. What is given in the question? Radha? Where is that girl? Sanjana?
I'm there, sir. Yes, sir.
Guys, please explain this question. Anyone over here, just raise your hand. There is a raising hand option. Okay, just click on this raise hand and you can just explain this question. Please try to explain. Until unless you explain it, you are never going to understand this. Have this confidence of explaining. Can anyone explain? Inchara? Inchara is new. Inchara, can you explain me the question? Inchara.
Yes, sir.
Okay, explain the question. Tell me.
I'm understanding, sir.
Still understanding.
Yes, sir.
Okay, Harshita will explain that. Harshita? After that, who is there? Darshini, are you here now?
Yes, sir.
Darshini is the only the person who have that confidence to handle the class is Darshini. Okay, Darshini, can you explain me this question? Still understanding, alright? Ankit, okay, where is my Tony Stark? This person will say Tony Stark.
Yes, sir.
Okay, explain. बस इतना बताओ. What is the given? What is it is asking in the question? Tell me. Tarun,
So we need to differentiate it.
differentiate it. Why we need to differentiate it? First, you have to tell me now what is asking in the question. How to understand about the question. Achha, okay, I am doing it. So till here, everyone will have the clear view that first, first of this full stop, that position of the particle is moving with this kind of equation on the x-axis. That is perfectly clear to all of you. But what it is asking, it is not asking velocity, it is not asking acceleration. That is the twist of need. Okay, they are not going to ask you the direct question. What it is asking, find the particular position where the particle reverses its direction of motion. Okay, so before going to that, first try to understand what is called reverse motion. Okay, so this is my road. Okay, word or not? So look over here. A car is over here. Car starts from here. I will tell you only. Look over here. Car starts from here. It has some final velocity v. It wants to turn from this side. Okay. So if it comes over here at this point p, it can turn it. Okay. Now look over here. If it is moving with velocity v, at point p, the velocity of car should be equal to 0 or not, so as to turn. Yes or no? Tell me, everyone. What should happen at point P to reverse the particular car or whatever you are driving? You need to make the velocity 0 or not of the forward direction. What I need to do? Velocity of forward finally should get down to 0. If it does not get down to 0, how come you can turn? Yes or no? Guys, can you answer me? Yes or no?
Yes, sir.
Okay, so what should happen? What should happen actually? The velocity at point P should get down to 0. Then only what will happen? The particle will be able to turn. So you need to calculate that first at what it is asking. It is asking the position where this velocity is going to 0. To calculate this position, try to understand, to calculate this particular position of the particle when this velocity is going to 0, first you need to know that at what time this velocity is going to get 0. If you know that at what time this velocity of the particle is going to 0, you can calculate x directly. I'll apply this time over here in the equation and I'll get the displacement of the particle as given about the concept initially. Yes or no? Okay, 100% okay or not? Tarun, समझ में आया अभी? Now are you able to get me or not?
Yes, sir.
Asparsa, Varun, Yasin, okay. Nisma, my head has started paining. Guys, please solve something. Okay. Harsita, now got it. Afan, Gunasri, okay, Gunasri has joined. Gunasri, are you able to understand this? Okay. After that, Ahmad, समझ में आ रहा है ना अभी ये सब क्वेश्चन?
हाँ, sir.
हाँ, तो यही सारी चीजें. धनुश्री, can you put the interest in this kind of questions or not? Darsani, are you able to get it? Now got the question? Okay, so this is the point, guys. You have to catch the things which are given in the question. Please try to catch it. Okay, I'm not saying you will get this kind of thing instantly. It takes some time. Okay, no problem with that. But try to understand this question, make the notes of it. So when the particular thing reverses, velocity should become 0. At what time, if you can calculate at what time this velocity becomes 0, you can calculate what is the distance over there. So look over here. I'll apply that first. I need to calculate velocity. So what is that? Here x is given, x is dependent upon time, so velocity will be what? D by dt of x of t. That is equal to what? D by dt of 220t minus 50t square. Yes or no? So what I need to do first, I'll just apply this differentiation on both of the terms. What it will do? D by dt of 20t minus d by dt of 50t square. Now look over here, 20 is a constant, 20 will come out, d by dt of t to the power of 1 minus 50 will come out also, d by dt of
Sir, 5 is square.
5t. Okay, okay, okay. Okay, so 5t square, got it or not? So 5t square. Now look over here. So I'm writing this. So this is my velocity. So what I will get? This is t to the power of 1. Here n is equal to 1. So velocity will be equal to 20. First I'm solving this equation. It is 1 t to the power of 1 minus 1 minus 5 2 t to the power of 2 minus 1. So what I get as answer? It is equal to 20. Something to the power of 0 is 1. So therefore this becomes 1. So 20 minus 5 2s are 10 t. And this is my velocity dependent upon time. Is I am clear or not? Are you able to understand this differentiation? Now differentiation you will not have doubts. Yes or no? Because sir has also started differentiation doing in the class. Okay.
Yes, sir.
Ah. Now look over here. We want to know that where this velocity is getting 0. So first I'll put this velocity to be equal to 0. That is equal to 20 minus 10t. So where the velocity is going to 0? After 2 seconds of after starting of the particle, and after time t is equal to 2 seconds, what is happening? Velocity of the particle becomes 0. Find the displacement in this, find the distance traveled by body in this time t equal to 2 seconds. So x, okay, I'm just minimizing this. So distance in total time t is equal to 2 seconds. What that will be? We'll have to put 20. Replace the value, yes or no? That's what we need to do. 20 into 2 minus 5 into 2s square. So that is equal to 40 minus 2 to the 4, 5 4 the 20. What is the answer? It is equal to 20 meter. So at the displacement of the, at x is equal to 20 meter, what is happening? Particle's velocity is going to be 0, and after that particle will start turning towards again back direction. So where the particle reverses its motion, at distance is equal to 20 meter, and after the time is equal to 2 seconds. Is I'm clear or not, guys? Is this perfect example? This is a perfect example of imagination. Is this clear, everyone? Oh.
Yes, sir.
Is I'm clear or not? Tell me.
Yes, sir.
I'm asking to Inchira, Dhanusri, Gunasri, because they are not able to write the questions. Now, can you imagine this kind of things? What will happen if the reverse is going to happen? Just imagine this in a practical way. Always try to imagine the questions in a practical way. Whenever the particle or whatever object is there, if it wants to reverse its motion, its velocity should become 0. Means this is the practical case. Okay, I'll draw this. Remember, try to understand all of you guys. This is my road. Okay. So if the particle wants to turn from here to here, if the car is over here, okay, if it is moving with velocity v, at this point the velocity should become how much? 0, so as to reverse. So for this velocity, what will happen? The particle need to travel some kind of distance d or distance x in some of time t. We can calculate using finding the velocity equation. Finding the velocity equation dependent upon time, put it equal to 0, you'll get the time, and then you can calculate the displacement of the particle. Yes or no? Okay. Okay, moving to next question. Solve this question. This is again easy. Already done. Please solve this question, guys. Look over here. Again, x, some kind of equation is given. Time, but as we know that time can't be written in terms of other things. So I'll have to convert it. So 3t is equal to root 3x plus 6. What I will do? I'll write root 3x is equal to 3t minus 6. But this will become 3x will become as 3t minus of 6 whole square, and x will be written as what? 3t minus of 6 whole square divided by 3. This is your position equation. Yes or no? But it is asking, it is again asking displacement when the velocity of the particle is 0. So first you need to know at what time velocity of the particle is 0. Replace that t with over here and you will get the displacement. Yes or no? So first calculating velocity, what I will apply? d by
So 0.
dt of x. It is becoming 0.
Yes.
Is everyone is getting 0? Check it. Harshita, Gunasari, Darsani, now can you solve? Please solve it, guys. Inchara, can you solve? Afan,
Yes, sir.
solve करो भाई जल्दी. Sanjana, Sneha, Sneha, what you are doing, Sneha? No reply to any of the questions. Asparsa, are you solving or not, Asparsa? Solve this question, guys. Please solve it. I'll check the result. Asparsa has scored how much? Right. In physics. Harshita, good. It is improving. 50 you have scored. Ankit, 31. Disha?
So if P is equals to 2, then displacement is 0.
Okay. Disha has scored good. Disha, you have joined now? 63 she have scored. Wow. Really great. No, Disha has performed really great. After that, Asparsa. 55 Asparsa, but this is not good. You have worked really hard, but you are not able to perform. Gunasri, please work little bit. Your marks are also increasing, but I need little bit much more. Okay. अफन थोड़ा और हार्ड वर्क करो यार.
ठीक है सर.
राधा, really यार, you need to work. This way it can't go. Sneha, you also, like, your marks are even less in chemistry, it's even less in biology. Gunasri, why your marks are less in biology? Gunasri? Hello? Please increase it, guys. Sanjana, yours also marks are less in biology, physics, chemistry. Wow. अंकित थोड़ा बायोलॉजी में और मेहनत करो. हर्षिता, प्लीज वर्क हार्ड ऑन योर सेकंड पार्ट ऑफ बायोलॉजी. ओके, you guys have, yeah, you guys need to work on biology also. Ankit, good, you have scored very good marks in chemistry, but तुम मेरा physics डुबा रहे हो यार. But
सर मैं आज तक एक बार भी प्रैक्टिस करके इस बार पक्का सर. इस बार बायोलॉजी छोड़ूंगा भी नहीं.
okay then.
बस फिजिक्स करके रहूंगा.
Okay, so dy dx of x निकालो यहाँ पे. So देखो, x is given as 3t minus 6 square again. Now 1 by 3, I'll write directly d by dt of 3t minus of 6 whole square. Now one thing is there, you can solve it directly or you can solve it indirectly. Again, here what has happened, one difference is there from previous case. Here one constant has multiplied with the variable. Now it is going to change. Okay, little bit there will be a change in the equation. Again, 1 by 3 first, this is again t to the power of n value, so it will be 2 3t minus of 6 to the power of 2 minus 1. But as there is a constant term multiplied with the variable, again you need to do apply this differentiation. Please try to understand this question perfectly. What I said, guys, here there is a little bit of difference. First, you need to differentiate with the normal fashion. Then after that, since a constant term is multiplied with the variable, again you will have to differentiate that particular term, that is equal to 3t. And you have to multiply with the original answer. Are you able to get me or not? Is this okay or not? Tell me. This is the silly mistake. First silly mistake, what? People will leave it till here, but there is another term over here. Inchara, okay or not? Is it okay? Asparsa? Okay? Okay, now look over here. What I will do, I can just write this 1 by 3, 2, 3t minus of 6 to the power of 2 minus 1, that is 1, multiplied with d by dt of 3t is going to be what? 3 will again come out, d by dt of t. What is going to be? 1 to the power of 1 minus 1. Now do not ask me how I have done. Please, little bit you need to do. So velocity will become as what? This is again t to the power of 0 and something to the power of 0 is 1. So therefore what I got as answer, 1 by 3 into this 3 will be multiplied over here, that is 3 to the 6 into 3t minus of 6. So that is what 3 to the 6, it is equal to 2 into 3t minus of 6. Did everyone got this as velocity equation? Please verify it. Radha, did you got this relation? No, na?
Yes, sir.
Got? Good, yeah. But what is happening in your exam, huh? 15, I'll kill you. I'll just kill you like anything. 15 marks you have scored. She is scoring very good marks in biology. Little bit, again, her marks in biology is also decreased this time. In chemistry also. Study Mari, okay. Now look over here. As you know, as you got the velocity equation, it is asked that displacement when the velocity is 0, put it to be equal to 0, 2 into 3t minus of 6. What I get? It will be 3t minus of 6 is equal to 0. T is equal to again 6 by 3, which is equal to 2 seconds. So after 2 seconds, what is happening? The velocity of the particle is 0. So displacement after 2 seconds is going to be equal to how much? X is equal to, what is the relation? 3t minus of 6 by 3 whole square. I'll put this t is equal to 2 seconds in this equation. What I will get? 3 into 2 minus of 6 divided by 3 whole square. Answer is how much? It is equal to 0. So which option is correct? Option D is correct. Okay or not? Is this okay or not? Yes or no? Okay.
Yes, sir.
Okay. Moving to next part. There is a theoretical question. What it is given, a body in one dimensional motion has zero speed at an instant. Okay. At that instant, it must have. Look over here. What it is given, a body has zero speed. Previous question, did anyone need to write it, or can I move to next question? Yes or no? Can I move to next question or not? Okay. Akash, you are telling something. Tell me. Is there any kind of doubt? Okay. Moving to next question. Okay. Solve this question. Tell me the answer. Write something, guys. Write the answers, guys. Please do something by yourself. Please. Those who will say the answer, correct answer of this question, I'll give one Cadbury chocolate tomorrow. Day after tomorrow. What it is asking, a body in one dimensional motion has zero speed. What it is given that you have a zero speed for the particle, zero velocity. Option C, everyone is saying zero velocity. Non-zero velocity, Ankit is saying. So if your speed is zero, if your what it is given, speed is given, not the velocity. Speed is itself, it is equal to how much? Zero. That implies what? Velocity will be first important thing. Zero. Magnitude of the velocity will be definitely zero. If magnitude of the velocity is zero, who said that acceleration will be equal to zero? Can you say me that acceleration is zero for the velocity equal to zero? Tell me. Can you tell me, guys? So now I'll give one example of this. Okay. So look over here. See this. Try to understand. Let's suppose a particle. Have you seen pendulum or not? You have seen the pendulums. Okay. So when the pendulum, try to understand, when the pendulum is at its extreme position over here, still it is at rest. But it has the acceleration component that is equal to minus g acting downwards. Yes or no? So that means what? If we have zero speed, we can't say that the acceleration will be also equal to zero. So 99% of the person will click which answer? Zero acceleration, because they know zero velocity, zero speed, whatever it is, acceleration should be equal to zero. But that is incorrect. What should be actually zero? If speed is zero, your velocity should be zero. What should be zero? Velocity should be zero, because velocity is nothing but it has the magnitude of speed. Right or not? Or you can say that the speed can be called as magnitude of velocity. So if speed is zero, what will happen? The velocity magnitude will be equal to zero, but direction of velocity will not be zero. If direction of the velocity is not zero, how come you can say that the acceleration will be equal to zero? Okay. So for acceleration to be equal to zero, two things must be definitely there. The first, magnitude of velocity should be also zero. Second, directional component should also be zero. If someone says that a is equal to zero, you need to remember 2 points. First, magnitude of velocity should be equal to zero. Second thing, direction of velocity should be also equal to how much? Zero, guys. But as is the speed is zero, only the magnitude of velocity is zero. So we can't say that zero acceleration will be possible. So which answer is correct? zero velocity is correct. Is I'm correct or not? Tell me yes or no. Okay. Okay.
Yes, sir.
Yeah. Moving to next question. Which of the following four statement is false? What is saying? Which of the following statement is false? Okay, go one by one with respect to the options. First option is what? A body can have zero velocity and still be accelerated. So this is true. Yes or no? Already I said over here. If your direction is equal to zero, then only the acceleration will be equal to zero, and magnitude of velocity is zero, then only acceleration will be zero. So here what is happening? Only zero velocity is there, not the direction of velocity is zero. So that means what? It is possible that we can also have the acceleration over there if I have velocity to be equal to zero. So remember this line: if velocity is given as equal to zero, that does not mean acceleration will be also equal to 0. What? If your velocity is 0, that does not mean acceleration will be also equal to 0. So this is true. Second case, a body can have constant velocity. What it is written? Constant velocity and still have varying speed. How is this possible? Look over here. What is speed formula? Speed is nothing but it is equal to magnitude of velocity, yes or no? Now, if you have velocity is as constant term, if your velocity is perfectly constant, speed will also remain constant or not, because the magnitude of velocity is not varying. So this is false. What is false? This is false, that speed should remain constant if your velocity is constant. Is I'm okay or not? Tell me. Is this okay or not? Yes or no?
Yes, sir.
Okay. Now look over here. Next thing.
Sir, what about 4?
What about fourth? I'm coming. Okay. Now, options third, a body can have a constant speed and still have varying velocity. Now, that is lookable. I can have a constant speed, yes or no? If your speed is constant, magnitude of the velocity will remain constant. What will remain constant? Magnitude of velocity will remain constant. But who said that the direction will not change? So look over here. Let's try to understand. Let's suppose the body is moving first towards east, then towards north. Here it has 5 meter per second. Here it has also 5 meter per second. Now look over here. So first body is moving towards east, then it is moving towards south. So speed remains constant or not? The magnitude of the speed remains constant. But if you try to see the velocity of the particle, first the velocity was in east direction, then the velocity is in south direction. So here actually, since velocity is a vector quantity, if direction changes, the velocity or the vector quantity changes. So that is why we can have a constant speed and we can have the varying velocity, because velocity depends upon direction. So this statement is true. Yes or no? Guys, is I'm correct or not?
Yes, sir.
Okay, now moving to fourth point, the direction of velocity of a body can change when acceleration is constant. Okay, fourth one we have to check. What it is given, the direction of a velocity of body can change. The direction of velocity of body can change when its acceleration is constant. Yeah, look over here, see this. Acceleration is given as what? V minus u by t. So now let's suppose your, try to understand. Here it was 5 meter per second square. Here it is 5 meter per second square again. So here initial velocity was in east direction, final velocity is in south direction. So what you will observe, try to calculate it. Let's suppose this change is happening within 2 seconds. If you will calculate the acceleration, what you will get? You will get 5 I cap minus 5 j cap divided by 2. Yes or no? Some kind of this kind of, I'm not going to this. I'll not write this because you will not be able to understand how I have written this. But you try to understand, if you change the direction of velocity, if I change the direction of velocity, the magnitude is not going to change. Yes or no? The magnitude of the velocity is not going to change. So therefore what will happen at that time? Acceleration will still remain constant. So one thing is there, see this. I'm just minimizing this. Try to understand what I'm saying, guys, that if direction of velocity, if velocity magnitudes are equal, acceleration is given as what? V minus u by t. So if you are not changing the magnitude of velocity, the magnitude of acceleration will never remain change. Yes or no? Acceleration will also remain constant. So if you are changing the direction, what will happen? The direction of A will change. So therefore, this is what it is true. What? That if your direction of the body is changing, its acceleration will also remain same, because only the direction is changing, not the magnitude of the body. So which statement is false? Option 2 is false. That for constant velocity, you can't have a varying speed. Yes or no? Got it or not? Guys, are you able to understand me? Are you able to understand this English? Yes or no?
Yes, sir.
Were you able to understand that English now? Inchra, Akash? Okay? Inchra, okay or not? Ahmad, okay? Gunasri, okay or not? Harsita, was that okay? So remember that whenever you have direction of the velocity to be changing, what is going to happen? Magnitude of velocity will not change, and therefore the magnitude of acceleration will also not change. Okay? Moving to next question. Solve this question. Question number 7. Something you should solve. This question is on you. Do it fast. Okay. How to analyze this question? I'll tell you how to solve this question in a very much faster way. So x is given dependent upon time. So something you will have different equations. Okay, as x you as from the box you will have 4 equations over here. Yes or no? X is dependent upon time. If x is dependent upon time, I can have utilize these 4 equations: 1, 2, this third, and fourth one. Now for different cases, I'll get the 4 results for this x of t. Here, go through the options. Here it is asking about what is happening at t is equal to 1 second and what is happening about t is equal to 2 seconds. So first calculate x. From this x, try to calculate first velocity dependent upon time. And if you calculate the velocity dependent upon time, check for t is equal to 1 second what is happening to velocity, check for t is equal to 2 second what is happening for the velocity, and you will get the answer. Yes or no? This is the most easiest trick. Okay. Are you able to get me or not? Okay guys, yes or no? I can't hear. Guys are sleeping now. Are you guys sleeping? Hello? Harshita, is I audible or not? Asparsa, hello? Okay. So if I am audible, please guys say yes or no. Okay. So you calculate the velocity first. So what will be that? Velocity of t will be equal to d by dt of x of t. And that will be what? D by dt of t cube minus 3ts square plus of 3t plus of 3. This is going to be equal to how much? D by dt of t cube minus d by dt of 3ts square plus d by dt of 3t plus d by dt of 3. Now, this will be what? 3 to the power of 3 minus 1 minus. This 3 will come out as it is a constant. This is ts square. So 2 to the power of 2 minus 1 plus. Again, this 3 will become out as it is a constant. 3 d by dt of t, which is equal to 1 to the power of 1 minus 1. Here it is only a constant. This value will become 0. So what I got as velocity equation? Velocity dependent upon time as 3t square minus 3 to the 60 plus of 3. This is the equation. Now check what I told. Check for t is equal to 1 second, t is equal to 2 second. What is happening? So velocity at t is equal to 1 second. What is that? It is equal to 3 into 1 square minus 6 into 1 plus of 3. So 3 plus 6, 3 plus 3 is 6 and minus 6 is equal to how much? 0. Velocity as t is equal to 2. Check it for that. 3 into 2 square minus 6 into 2 plus 3. How much is that? 4 3 is 12. 3 meter per second. Now look over here. Options are given for reverse case or not. Yes or no? So as you know from previously I only discussed when the reverse will happen when the velocity after time becomes 0. So look over here, in which case velocity after time t is going to be equal to 0. As you observe that after time t is equal to 1 second, velocity of the particle becomes 0. So that means what? Particle, if you see option 1, what it is written, stops at t is equal to 1 second, stops at t is equal to 1 second and reverses its direction of motion. Is it correct or not? Yes, answer is correct. Why? Because when you observe at t is equal to 2 second, again the velocity of the particle, wait, not reverses its direction of motion. Here velocity of the particle is what? Positive. So that means what? First the particle stops at t is equal to 1 second. As the t equal to 1 second, what is happening? Velocity of the particle is becoming 0. So particle stops at t is equal to 1 second. But at 2 is equal to 2 second, at t is equal to 2 second, if you see the velocity, it is again positive. So that means what? Particle moves without changing its direction of motion. So after t is equal to 1 second, what is happening? Particle is still moving with increasing velocity without change of the direction of motion. So which option is correct? Option B is correct. Yes or no? Are you able to get me or not?
Yes, sir.
Is it okay?
Yes, sir.
Okay na? Harshita, Akash, Darshini, are you able to understand all of these things or not? Is it okay or not? Darshini, you need to perform. Inchara, okay? Parinita, Sanjana, Asparsa, okay or not? If you guys didn't score now, I'll kill you next time. Question number 8. Solve this question. It's a very good question, okay? If you can imagine it, it's awesome question. I have increased the level of question. Please see, a little bit it is of increased level, level 2. I'm not saying it is an easy question. Okay. Ahmad, option 3 is correct. Option 3. Let me just check. Ahmad. Ahmad, Illa. Acha, what it is given? Time is given. Time is equal to ax square. Write the equation first plus beta x. Okay. Alpha x square plus beta x is given. What is asking? Retardation it is asking. As you know, retardation is a negative of acceleration. So if we can get acceleration, we can definitely get retardation. Now, acceleration is what? Acceleration has two formula. First, you apply dv by dt. If you calculate velocity, if you differentiate with respect to time, you can get acceleration. Or from the position, you differentiate it two times. So d by dt first time, again d by dt of x. If you can do, you'll get the acceleration. So you have a three-step process here. What you observe from the equation, that in the equation, what is mentioned? It is mentioned time is given, first variable, second variable is your position, x is given. Oh, x is given, that's correct. But here, to calculate acceleration, it is given in an indirect way. You can't calculate it easily. So, how to do it? That's the biggest question. Yes or no? Guys, yes or no? Tell me. Isn't it a biggest question? How to solve this problem? So, how to do it? Let us see. See this, how I will do. Please observe how I am doing. Okay. So, now look over here. T is given as alpha x square plus beta x. Okay, so I have to form the equation of acceleration. How I will do? Can I apply the differentiation on both of the sides? What I'm doing the differentiation with respect to t on both of the sides. Okay, so it is equal to d by dt of alpha x square plus beta x. Correct or not? First step what I did, I applied differentiation of both of the sides. Yes or no? Is it okay or not? Tell me. Clear? Now this is t to the power of 1. Simple, logical. What will be the answer? D by dt of t to the power of 1. 1 to the power of 1 minus 1. Okay. Next thing is what? Here, you try to understand x is representing position. Position is always going to vary with respect to time or not. It is never going to change. So what will happen? This constant will first come outside, alpha will come outside, and then it will be applied as d by dt of x square. Here beta will come outside, and it will be having d by dt of x over here. This is the process or not? Tell me yes or no.
Yes, sir.
Okay, Asparsa, Sanjana. Darsari, okay or not? Gunasri, okay. Harsita, Disa, is it okay or not? Ahmad, Tarun, okay. So now look over here. Now here it is the twist which is going to come. Now x is dependent upon time. Here it is differentiation of with respect to t. What is going to happen? You have done yesterday. I seen day before yesterday Sikya sir was doing that this kind of parametric form. So now look over here. Here you will get as 1, but here what you are going to get? So first, x is dependent upon team. Here it is another variable. Look over here, understand this. So if you have d by dz, and here it is y, which is varying with respect to time. So let's suppose y to the power of n is given. Okay, so what will be your answer? First n y to the power of n minus 1. Then you will have dy divided by dz, extra term multiplied over here. If these two variables are not getting matched and y is dependent upon z, so what you will get the equation? N y to the power of n minus 1 dy by dz. This is your relation. Understood or not? Is it okay or not? Tell me. Okay, so therefore here also x is dependent upon t, but here there is the variables are not matching. What I will get? I'll get 2x to the power of 2 minus 1 into dx by dt. Yes or no? Is this will be the step or not? So are you able to understand this twist or not? Tell me yes or no. Is it okay?
Yes, sir.
Okay,
Yes, sir.
good. This is the process. This is I'm dealing with in a simple way, going through every step. Okay, please understand it. If you'll have doubt, again I'm going to explain. So this was the twist over here. Okay, so let's suppose I will take another thing. If let's suppose if I take d by d of sagalaka boom boom m. Okay, so m, and here it is x to the power of n is given. It is said that x is dependent upon m. What you will get as answer? Nx to the power of n minus 1 dx by dm. You will have an extra term over here. Word or not? So similarly, I got extra term dx by dt over here. So beta, here x to the power of 1 is there. So 1 x to the power of 1 minus 1 into dx by dt. So one extra term again came over here. Understood? Yes or no?
Yes, sir.
Hmm. Okay. Now look over here. See this. What I got as answer? 1 is equal to alpha 2x to the power of 2 minus 1. So it is equal to 2x dx by dt plus beta. Here it is what? Again 1 will come. It will remain as dx by dt. I can take dx by dt as common. This implies dx by dt I can take as common. And I'll write this term. It is equal to beta plus twice alpha into x. Right or not? Is it okay? Twice alpha into x is there, no? Yeah. So twice alpha into x, and that is equal to how much? 1. You got as what you got your dx by dt equation? Dx by dt you got as 1 by beta plus twice alpha x. Now look over here. Can you see the chamatkar? Can you see the chamatkar of this question? As you know that dx by dt is what? It is called as velocity. So did you got the velocity? Yes or no? Are you able to visualize this chamatkar or not? Did I got my velocity or not? Yes or no? Guys? Now, try to understand again. Is this velocity is dependent upon time? The answer is yes, because it is dependent upon position. So, if this velocity, if you have got this velocity, you can apply the acceleration equation. As you know, that acceleration is what? As I know, first I'll write the velocity over here. This velocity is nothing but it is equal to, okay, let me do it in this space only. Very, very much good. Okay, so here you got your velocity as something 1 by twice of alpha x plus of beta. As you know the velocity, you need to calculate acceleration. Now again a twist has came, guys. So as you know, acceleration is written as dv by dt. Yes or no? But I can write this as what? I can write this as dv by dx into dx by dt. Yes or no? If I multiply dx on the both side, this and this will get cancelled or not? But try to understand. I got one extra formula from this. What is that? That dx by dt is nothing but it is velocity. Yes or no? So you got one relation for acceleration, and that is equal to v into dv by dx. What you got the acceleration equation? Velocity into dv by dx. Is I am clear, guys? Is this thing is clear or not? One extra equation for acceleration. Yes or no? Is this getting hard? No, na. Darsani, is it getting hard? Yes or no? Little bit hard it is. Yes, I will accept that it is hard. So you have to do it. Yes or no? Everyone, please concentrate over here. It is hard. Yes, I am accepting it. It is hard, but you will have to do it. Yes or no? So now do it again. So acceleration has formula what? Velocity into dv by dx. What is given means why we are approaching this formula, that is the biggest reason. So as you see over here that in velocity in RHS there is x, not time t. So acceleration equation should also have x dependency, right or not? And this I can get it from this particular equation which we need to follow. So remember that in this box I'll again write one extra formula over here. See this. So all of these were dependent upon time, but the question is if velocity depend upon position one time. Okay, so last for, so at that time you can only calculate acceleration and the formula will be v into dv by dx. So last form is this. Okay, so first see, first you have four formula for x dependent upon time, then you have three formula for velocity dependent upon time, then you have two formula for acceleration dependent upon time, and if velocity become dependent upon position, only one formula. So this is the trick. Understood or not? 4, 3, 2, 1. You need to remember 4, 3, 2, 1. So if velocity is dependent upon position on RHS, if you see in velocity, if there is a position, which formula we need to apply? A is equal to v into dv by dx. As I got from here in this question, what we observe, that velocity is dependent upon position. Acceleration will be what? Velocity first, 1 by 2 alpha x plus beta into d by dx of 1 by 2 alpha x plus, sorry, 1 minute, 2 alpha x plus of beta. Till this step, is it clear or not? Tell me, guys. Is I'm clear or not? Everything is clear? Okay. Darsani, okay? Gunasri, okay? Ahmad, okay or not? Ankit? Dhanusri? Are you alive, Dhanusri? After seeing this kind of hard questions? Dhanusri, is it Subhasri or Dhanusri? Who is that? Subhasri, no? Yes. I forget your name always. So Subhasri, are you alive after seeing this kind of questions? No problem, na? Inchara, okay?
Yes, sir.
Pranita, okay? Sanjana, Asparsa? Asparsa, okay or not? Tell me. Asparsa, your best friend is not here. Where is Vaishnavi? Huh? She will die after seeing this kind of questions. Okay. Okay. So acceleration will become as what? 1 by 2 alpha x plus of beta. Radha, are you here? D by dx of 1 by alpha x plus beta. Now you can solve this. Can you solve this differentiation d by dx of 1 by 2 alpha x plus beta? Who will solve? Just do it. Oh, I'm dying. I'm dying so hard. I'm begging, begging you. Can you solve this? Who will solve? Next step. Let me solve. You guys will die. Okay, so see this. Again, I will apply the trick. Alpha is equal to 1 by 2 alpha x plus beta. Now look over here. I can write this as what? D by dx of, see this. What I can write? D by dx of twice of alpha x plus beta to the power of minus 1. Can I write like this way or not? It has become easy as you can consider n to be equal to minus 1. What you will get? Alpha acceleration is equal to 1 by twice of alpha x plus of beta, and this term will what? Minus 1, n is minus 1, twice of, okay. So I'm doing it in the next phase, okay, because I want to do it clearly. Next, okay, so look over here. So acceleration was equal to 1 by twice of alpha x plus of beta, first thing, and you will get over here d by dx of similar equation twice of alpha x plus of beta to the power of minus 1. Now look over here what I get as an acceleration. Okay, it is equal to 1 by twice of alpha x plus of beta bracket. This is n equal to minus 1. So minus 1 x to the power of twice of alpha x plus of beta to the power of n minus 1. So minus 1 minus 1 you will get. Yes or no? Then again there is a constant term multiplied with x or not. So you will have differentiation of d by dx of twice of alpha x. So of course it is a hard question because it involves so much of trickiness. So this is 2 alpha into x plus of beta, outside term. Inside term is what? Minus of 1 twice of alpha x plus of beta to the power of minus 2 d by dx of twice alpha x. So 2 alpha will be considered as constant. D by dx of x is going to be equal to what? Again 1. So therefore you will get an extra term 2 alpha over here. Okay. So what I got as an answer? 2 alpha divided by 2 alpha x plus of beta. Now, if this is minus 2, that means what? In denominator, it will become as a square, and minus 1, I'll multiply it over here. So it will become negative 2 of alpha x plus of beta square. What is this? Minus of 2 alpha divided by 2 alpha x plus of beta to the power of 3. And that is my acceleration. Is any kind of doubt till now with all of these steps? Tell me, is any kind of doubt with all of the steps? Please repeat it once again in your home so that you can get the answers. Okay, so what I get is my acceleration over here. Acceleration is nothing but minus of 2 alpha divided by 2 alpha x plus of beta to the power of 3. As you know, what is the velocity? 1 by 2 alpha x plus beta or not? So can I write acceleration to be equal to minus of 2 alpha into velocity to the power of 3? Now, retardation, we have to calculate the retardation as given in the question or not? Retardation, what? It is equal to negative of a, that means what? It is equal to 2 alpha to the power into v to the power of 3. So what is your answer? Is it given? Yes, the option 1 is correct. What is your retardation? हाँ बताओ. कहाँ बेटा? कहाँ पे बेटा? हाँ तो देखो वेलोसिटी क्या है? 1 बाई 2 अल्फा एक्स प्लस बीटा है कि नहीं है? तो ये तो तुम लिख सकते हो ना कि 1 बाई 2 अल्फा एक्स प्लस बीटा टू द पावर ऑफ 3. यस और नो? तो ये होल टर्म वेलोसिटी हो गई कि नहीं हो गई? सो वेलोसिटी टू द पावर ऑफ 3. यस और नो अमर? ठीक है. Is it clear with you all of you guys? Yes or no? So this was a hard question, but it was kind of a good. You can understand what will happen with all of the types of differentiation. So I discussed every kind of differentiation till now. Okay, is it clear or not, everyone? Tell me. Okay, Ahmad, Darsani, okay, Gunasri, okay, Asparsa, okay, Tarun, okay or not? Varun is here, Magdumullah Khan is there, Injara, okay,
Yes, sir.
Disa, okay or not? Akash, uh, okay, okay. Subhasri, is it okay or not? Tell me. Are you able to understand? Okay, I'm not saying that if you will be if you will not be even understanding, please do it. I'll send the PDF of all of these things, and most importantly, practice it one time. You can ask me directly in the classes also. I'll deal it with this kind of questions once more. Okay, so we'll move to next question. Let us do it, and the question number 9. Okay, so there are how many questions in part 1? I think there are total 13 questions in part 1. After that, again, part 2 will come. Okay. So part 1 have total 13 questions. We'll try to complete all of these 13 questions. Okay. Please, guys, be with us. Guns, as in PUBG, you will see that there is one frame. It says guns be with us. So, guys, be with us and solve the problems. Solve this question. Question number 9. Two. Ahmad, option 2 goes on increasing with time. So this question is really, really great. Yeah? Means it requires a good concept. Okay. What I will do? Okay. What actually? I think it is already going to be 10.